just yell at you every time we need to yell. Hey, Laura, this is R7. We're doing the second half of it. You should maybe hopefully have these homework problems done. We're going to do the last 3 examples today and then those 3 homework problems. Here we go. I don't know. Whatever. Okay. I'm sorry. Not really. Example 4. Here we go. 4 in the notes. A mail order company. At a mail order company, Derek can process, I can't read today, 100 orders in 4 hours and can process 100 orders in, Miguel can process 100 orders in 3 hours.
You're struggling.
Blah, 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 blah. Okay, how long would it take them to process 100 orders if they work together? Okay, so
over 200.
we have efforts, right? Let's talk about like part A, okay? We have effort here and we have effort here, right? Okay, and we're going to talk about their unit effort, right? Unit effort and unit effort, okay? Derek can do 100 orders in 4 hours, right? So how many orders can he do in 1 hour?
25.
He can do 25, right? Okay, so what fraction of, let's see, 25 orders in an hour. So is this how this works? He will do 1/25 of his orders in an hour. Is that true? No, not right. Not right. Let me look this up. Hold on, before I lead you astray. Right, a quarter of it. Yeah. Hold on. Let me look this up before I lead you astray.
That's what we try to do because of the day you're
My brain's not working right now, so just give me a second.
It's actually really helpful because like they
Quadratic applications work. Yeah. Okay. All right, never mind. I lost it. Unit. He can do 1 job in 4 hours. There you go. That's what I want to look at. I want to look at 1/4, okay? And the other person can do 1 job in 3 hours. Okay? And so what they want us to do is if they combine those efforts, which means we're adding them together, how fast can they do 1 job? So we put X hours as our bottom, right? 1 job in 4 hours, 1 job in 3 hours. If we combine those efforts, we can do 1 job in X amount of hours, okay? So I've got 1/4 plus 1/3 equals 1 over X. How do I do this?
So if I'm wrong,
It's 2 over 7.
Common denominator? No, wrong. Common denominator, 4, 3, and X are my denominators, so I need 12X, 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 right? Okay? 1, 1, 1, and I'm going to multiply by what they need, right?
3x.
Okay? This first guy, to get from 4 to 12x, I need to multiply by 3x, right? To get from 3 to 12x, we have to multiply by 4x. To get from x to 12x, we need to multiply by 12. Not 12x, just 12. Okay? And then we cross the bottoms out because there is an equal sign. So I've got 3x plus 4x equals 12. Are we good to go? 7x equals 12, and if I divide by 7, it takes them how long? 1 5 sevenths, which is 1 point, I don't know. Give it to me as a decimal.
1.67.
I don't think so. 1.
2 or something. No, 1.6.
Can I get a drink? The pretzels are
It's
dry.
probably close to 1.67.
Okay, they just leave it as 1 5 sevenths.
Trevin, can I get a drink?
1 5 sevenths hours.
I don't know. Can you?
They can finish the job in 1 5 sevenths of an hour, right?
Guys, I lost my
It's
couch.
7
Okay, but then we got to do part B. They just leave it as 1 5 sevenths, okay? How long would it take for them to process 1,400 orders if they go together, okay? This 1 5 sevenths is how many orders?
1 hour.
100 orders, right? So I have to take this number and I have to multiply him by
14.
And I'm going to go 12 over 7 times 14,
Over 1.
right? Over 1. Okay, I'm going to leave that as 12 over 7. Okay, and if I reduce those, that would be 24 hours. It would take 24 hours to process 1,400 orders versus 100 orders if they work together, right?
3 business days.
3 business days, true. As long as you didn't have any other projects to work on. And assuming you have 8-hour business days.
Can I get a drink?
You were efficient for all 8 hours of it.
If you're gonna go get
Correct.
a drink, can you fill my
Correct.
water, please?
Correct.
Yeah.
Okay.
Where do you get the little styrofoam
Take a
cups?
drink.
In the teacher's lounge.
So, you don't need a
You
drink
cannot.
from it.
Okay.
Is that coffee?
Example 5. What?
Is that coffee or hot chocolate?
No, it's coffee. It's cold coffee, actually, because I haven't. It's been sitting on my desk for an hour.
What? There's more styrofoam cups. Can I please get
That's got old coffee in it, though. You probably don't want that. Okay.
Put that coffee back.
All right, example 5. Let's go. A window is in the shape of a rectangle with an adjacent triangle above it. It is a right triangle above it. Yeah? Okay? The length of one leg of the right triangle is 2 foot less than the length of the hypotenuse. And then the length of the other one is 1 foot less than the hypotenuse. That's where they get this. Here's my hypotenuse. They labeled as x. This guy is 2 less than that. This guy is 1 less than that. Okay? No, it's not. But you can figure out what it is. Find the lengths of the sides. All right? So we've got this relationship. We do know that it is a right triangle, so we can do what?
Add. Honestly, I bet it's a 4, 5, 3, 4, 5.
It is. It is.
Oh,
It
my
is.
bad. 3, 4,
But
5.
if we don't know that it's a 3, 4, 5, how do we solve it? Very carefully. It's a right triangle.
X squared minus 1 squared plus x squared.
A squared plus B squared equals C squared, right? Okay, which side is side A?
Any side.
No,
besides the
not
high
any side.
top.
No.
Right.
C-
So let's
C
say
is
A is this guy, B is this guy, C is this guy, right? Okay, so if I do A squared, this is x minus 1 squared plus x minus 2 squared equals x squared. That's side C. Now, a bunch of you have already figured this out, that this is a 3, 4, 5, because that's the only combination that makes sense, right? 3, 4, 5, that would be 1 less, 2 less, and then x, right? Okay, but this is assuming we don't already know that, because on the homework assignment, they're not going to probably have ones that come out nicely, right? They're going to have like decimal numbers, okay? So how do I deal with it when we do that? All right, let's see. These guys, we got to FOIL them out, right? So x minus 1 squared means x minus 1 times another x minus 1. Let's FOIL. X times x squared,
It's negative.
minus 1x minus another 1x plus 1. That's what he is, right? Okay?
Yep.
Now let's do this guy. So x minus 2 times another x minus 2. He is x squared minus 2x minus another 2x plus 4. Then we got him equal to x squared on this side. And let's combine stuff. Okay? Do we see what we're doing? Yeah, let's combine stuff. X squared and x squared, that is 2x squared. All right, we've got minus 1x minus 1x minus 2x minus 2x. Minus 6x, and then
Plus 5.
plus 5 equals x squared. Okay, now what do we do?
Subtract an x squared.
I'm going to move the x squared over here, right? So that makes him now a
Simple trinomial.
simple trinomial. That's super nice.
X
Okay.
minus 5, x minus 1.
Okay, multiply to get 5, add to get negative 6.
X minus 5, x minus 1.
X minus 5, x minus 1. Okay, so x is equal to 5 and x is equal to 1. Can those be legit answers?
Yeah.
Yes for now for x, right?
Not
But as
one,
soon
though.
as I go to plug back in, right?
It can't be 1.
This side could be 5 or this side could be 1. But when I start to do the other ones and I plug this in over here, 5 minus 2 gives me 3. 1 minus 2 gives me negative 1. So this can no longer be a combination anymore. Does that make sense? Okay? Then if I plug 5 in here, this side is 4. So this is a 3, 4, 5 right triangle, which a lot of you guys knew already just by the way that it was positioned, right? Okay? Good, good? But that's how that works. So 1 could have been an answer, but when we start to subtract 2 and subtract 1, that can't be an answer any longer, right? Questions about that? Okay. All right, not so bad. Those are quadratic equations that we're solving, okay? And then the last one is talking about projectile motion. This is what you learn, hopefully, maybe in physics, right? Okay. Here is projectile motion. Let's talk about this equation for just a second, all right? So we have S is representing the vertical position or the height. Sometimes they'll say height of an object, okay? And we know that, maybe we know, that when we launch something or when we kick something or when something comes off a cliff, that it does one of these, right? Okay? If we're kicking it like from the ground level, it's going to do a parabola. It's going to go up. What goes up must come down, right? In a parabolic motion, in a quadratic motion. So this is the formula of x squared, right? Okay? Even if, let's say we're on a cliff, right? And we take a rock and we kick it off the top, it's still going to do a parabolic motion, but this half of it is like not there anymore, right? It's still going to do a parabolic motion. Got it? if you throw it down, let's say you throw it off a cliff, it's probably still going to do like a little bit of one of those, right? It would just be like you're throwing it from the vertex at the top, right? So it would be only that half, okay, of the parabola. Yes, sir?
Also, depending on your frame of reference, you can't have negative numbers.
Correct. Yes. So like this would be the y-axis, and you would be going back negative to like figure out where he would intercept the other side. So yeah, you're right. Okay. All right. Now, this is the formula that they have going on here for the different variables that are in place. So let's talk about this. 1/2 g. This is representing like the gravitational pull, right? So g. Let's see. G is the, where is he? The acceleration due to gravity. Okay. Do you guys know what acceleration due to gravity is? 9.8 meters per second. Okay.
32 feet per second.
We learned this.
Or 32 feet per second, right? Okay, so let's write that down. Oh, it is? Oh, you just didn't know that already? Shoot, I was excited.
I knew that one.
Did you know the 32 and the 9.8? You knew 9.8, but you didn't know 32? Okay. So a lot of times you'll see this formula written as negative 16t squared. That is just showing you that we are in feet per second, true? Because half of 32 would be the 16, right? So you'll see that a lot. That's just noting that we are in feet per second, okay? Otherwise, it would be like 4 point, whatever it is. 4.5, no. 4.9. Negative 4.9 t squared. That would be in meters per second, right? Okay, the half incorporated in there, all right? So gravitational pull depending on meters per second or feet per second. Now, the velocity. V naught is the velocity that it is when it takes off. So if I'm launching like something out of a t-shirt gun, maybe it starts off going super fast, right? If I'm dropping a rock off of a cliff, it's going to fall at a different rate than if I throw it straight downward, right? That's the initial velocity. If I drop it, it has an initial velocity of 0, right? Because I'm starting, if I throw it, it's going to have a velocity, right? Like it's going to have whatever the velocity I throw it at, right? Okay, so there's that. And then S naught is the initial height. So am I kicking it from ground level? Am I throwing it from like arm level? Am I kicking it off of a cliff that's 100 feet in the air? We don't know. That's what we plug in for that, right? This is the elements of this equation. So down here we go. Write a model that represents the height of the rocket. That's what we're doing in part A. So we're basically taking all this information and we're stuffing it into this equation. Here we go. Part A. A model rocket is shot straight upward from a launch pad that is 1 meter above ground. Okay, so what is the 1 meter representing? The S naught. That's my initial. The naught is like S at a time of 0, right? What's the height? At 0 time, it's 1 meter above ground. So that tells us that our G is going to be what? 9.8, because we're in meters per second, that unit, right? Okay. All right. And initial velocity is 24. What's 24?
T.
V naught is 24. That's our initial velocity, a velocity at 0, right? Okay.
Actually, shouldn't the gravity be, because we're in meters per second, not meters per second squared?
What do you mean?
Doesn't it change?
No.
Meters per second squared is acceleration.
Yeah, is acceleration due to gravity versus velocity is per second. No, you're fine. You're fine. So we will eventually, but in part A, we're just writing the model. So model says S equals, is it negative? Why is it negative, by the way?
Because you lose. Well, it goes down. So it's inverted.
Yeah, the parabola is a downward parabola, right? And in order for it to be a frowny face, it has to be a negative parabola, right? Okay. All right. And plus S naught. We will find also that sometimes you'll get an answer where velocity is negative. Did you know that? Okay. Velocity being negative means what? It's falling toward the earth. Velocity that's positive, it's on its way up. So when we are launching this thing, are we launching it up or down? Up. So this velocity, the 24 is going to be a positive 24. So maybe make note of that because sometimes they might try to trick you in a homework assignment. I hope not. But if you're throwing a rock down, that velocity will start out with a negative velocity. Does that make sense? Because it's falling toward the earth. So just FYI. Just FYI. Okay. All right. So we got to plug stuff in. So S equals negative 1/2 G. We know that G is 9.8. Let's go ahead and do 1/2. That would be negative 4.9 T squared. T is going to stay as our variable, right? Plus 24 because we're launching it up, right? T And then plus 1. There you go. There's part A. That's our equation that we have. Now they're going to have us actually solve for stuff. So B says, find the time or times at which the rocket is at a height of 20 meters, okay? Are we going to have 1 time or 2 times?
Depends if it goes above.
It depends, right? But we are launching it from how high? 1 meter. So what's happening in part B is we're launching it from 1 meter, so we're not all the way at ground level. It's doing one of these, right? That's going to hit the ground. Are we going to hit 20 meters 1 time or 2 times?
Depends.
I guess it depends on if my height is above 20, right? Okay. If my height is above 20, let's say my maximum height is like 60. I don't know. Is it going to hit 1 time or 2 times? Twice, right? Okay. So we got to be careful of how that works. If we're launching it at like 30 meters above, like let's say we're on a cliff, he's only going to hit 1 time on the way down, right? Making sense? Okay. All right. So we've got to figure this out. So find the times at which it is 20 meters. Okay. So where are we plugging 20 into? The y coordinate s, right? This guy is 20. So 20 is equal to negative 4.9 t squared plus 24t plus 1. How do we solve this thing?
Very carefully.
What?
Move the 20 over. Move the 20 over.
You want to move the 20 over? You know what? I'm tempted to move all this junk over to this side so that my t squared is positive. Do you care? Sure, let's do it. Okay, so that will make my 4.9 t squared be positive. I just like to have him positive. I don't know why. Minus 24t, and then what? Plus 19 equals 0, right? Okay, how do I solve this thing now?
Well, plus 19. Oh.
Because I have to subtract the 1 over.
Put it in
Yeah.
ChatGPT.
No.
You could.
Complex.
Photo
You have to
map.
do
What times 4?
He's a complex trinomial, but he's like got decimals. I'm going to do the quadratic equation. Yep. Negative b will be 24 plus minus the square root of b squared. 24 squared is like 576. I don't know. What's 24 squared?
Probably more than that.
No, I don't know.
576.
576. Minus b squared minus 4 times a is 4.9 and c is 19. All over 2 times a, which is 9.8. Right? 2 times 4.9 is 9.8. Okay, we got to do this. What's 4 times 4.9 times 19?
A big number.
Maybe.
Not bigger than 576.
Correct.
372.4.
372.4? Okay, is that a positive 372.4 or negative? You're subtracting him, right? Right? Okay, so what's 576 minus that?
Math.
Like
203.6.
203.6. Okay. What is the square root of 203.6? Sorry. Like 11 point something. No, wrong.
14.268.
14.368. Okay. We're going to get 2 answers, true? Oh, 6.67.
7.
Okay. Whatever. Are you lying? How do I find my 2 answers then? 24 plus 14.367 divided by 9.8 and 24 minus 14.367 divided by 9.8. We're going to get 2 decimal numbers and they are, I don't know, somebody get them.
I'll do the bottom one.
What'd you get, Ella?
3.915 for the plus. Or maybe
We'll go 3.92 seconds.
The bottom one is
Sorry. I don't know.
not that. 22 point. No, it's not 22.
24 minus 14.
Hey, let me do it.
I bet it's like 0.67 or something.
No, I don't think so.
I got
0.98267.
Dang it.
0.982. So 0.98 seconds.
Go a couple more.
No. So, like we're shooting it from 1 meter above, right? And it's going up and coming down. This place at 20 meters above is hitting it at like less than a second in the air, right? And then it's coming down at 3.92 seconds in the air, right? It's hitting that same spot again vertically.
That rocket sucks.
Well, I don't know what the maximum height is.
That's like the only time I've only.
Well, I'm gonna guess that they're trying to go to outer space.
Okay? All right, good? Okay, now let's do this. Find the time or times at which the height of the rocket is 40. So instead of doing 20, I'm going to switch this number to 40. And let's see if we can do this. C. We've got
Another Pythagorean theorem.
We've got 4.9 t squared
Negative 4.
minus 24t. But this time, instead of plus 19, he would be plus 39 equals 0. And we're going to do a Pythagorean theorem again, right? Okay. Negative b is 24 plus minus square root of 576 again. Not Pythagorean theorem. We were doing the Pythagorean theorem first period, and it's still in my head. Minus 4 times a times c all over 2a, which is 9.8. Okay, what do you get? 4 times 4.9 times 39.
Probably a big number.
Probably a big number.
764.4.
Mm.
6, 7.
Tell me this.
7, 6.
So 576 minus 764.4.
It doesn't reach 40.
We are going to end up with an imaginary number, right? Because we'll end up with a negative, right? 24 plus minus the square root of a negative in here, whatever that number is, over 9.8. The fact that we got a negative means an imaginary number, which means that
It does not reach.
it's not going to touch 40. 40 is above where he's going to launch to, right? Yes? Does that make sense?
Or below.
No. No, because he's going up and coming back down. So we know 40 has to be above. Yep. So, what's the answer to part C? Find the times at which the rocket has a height of 40.
It will not reach.
Doesn't reach 40.
No.
Does not
Tigers is wrong.
reach 40. 40 meters. Do we see how that works? Why that is? Yeah. So that's a real world application of like when we would get imaginary numbers. We know we get imaginary. That means that solution is not an option for us, right? Okay? Good? All right. 3 homework problems, and that's all. 22, 30, 36. There you go. Add those.
Ella is going to get my gym bag because I gave her food.
Okay. All right. Get to work. Get going. Goodbye, Lauren.
She's going to be cut in half.